Hello my dear students, it's a pleasure to meet you in our educational program of Geology and Environmental Science. I'd like first to congratulate you and hope a new school year for all of you full with ambitious and hope and ends with successful exam and full marks. Let's start with the following. Now, my dear students, let's start to have a look to our syllabus of the geology program. We have the construction and constitution of the planet Earth and the geological structures, primary and secondary structures. Also, we have minerals and rocks. In another chapter, we have environment and the balance between geologic activity. We discuss continental drift and theory of plate tectonics. Another chapter is discussing equilibrium between atmosphere, lithosphere, denudation, erosion, and deposition, where we discuss rivers, streams, delta and groundwater, oceans, seas, lakes, lacustrine, and soil. Now let's start with the first chapter with this topic. What are the branches of geology? Let's start with the first branch. Physical geology is a branch which is mainly concerned with the external and internal processes affecting the surface of the Earth's crust. The second branch here is mineralogy and crystallography. They are related to the study of rocks, minerals, and crystals. Another branch of geology is economic geology and mining geology. They are separate branches which deals with the evaluation and the exploitation of ore minerals. The other branch is geomorphology. It is the study of relief and topographical features of an area of a region. Geochemistry. It is specialized in the studying the chemical side of the distribution of minerals and rock elements in the Earth's crust, and determine the type and the properties of minerals in the Earth's crust, also their proportion. Hydrogeology. This branch is related to whatever concerns groundwater aquifers, supply and withdrawal and use of water in agriculture and land reclamation. Structural geology. This branch, which deals with the shapes and structures of rocks and the movements that affect the Earth's crust. Stratigraphy. This branch elucidates the rules and environments that govern the formation of the layers and the sites of the position of the sediment after their weathering and transportation. Paleontology. It deals specifically with the study of fossils and the remains of living organisms like vertebrates, invertebrates, plants that characterizes the environment of the deposition of these rocks. Engineering geology. This branch of geology deals with the mechanical and engineering properties of the rocks in order to establish the different engineering structures such as dams, tunnels, bridges, giant skyscrapers, and towers. Petroleum geology. Petroleum geology is a specific branch that is concerned with oil exploration. Also, environment of its formation, accumulation, reservoirs, traps, structures involved, and production. Geophysics. This branch, which deals with the exploration of oil traps, groundwater, and ore deposition and deposits using physical concepts. Now, my dear students, let's go to another side of the introductory part of this chapter. What is the importance of geology in our lives? We can use geology and get benefits from it by exploration for minerals. Exploration for minerals such as gold, iron, silver, and other materials. Also, we can detect the different energies. Detect the different energies such as coal, petroleum, natural gas, and radioactive minerals. Find various building materials. Find various building materials such as limestone, marble, and chert, and gypsum stones, and other materials. Help in urban planning, as planning projects such as building new cities and the construction of dams and tunnels, safe ways of hazards and disasters. Search for raw materials used in chemical industry such as sodium, sulfur, and chlorine. For the manufacturers of fertilizers and pesticides and drugs in general. Detection of groundwater. This is one of the important resources, such as rely on the land reclamation as contribute to the success military operations too. Constitution of the planet Earth. This is good subject for understanding the Earth's constitutions. The Earth is described as concentrically zoned planet, which is divided into the following zones. The crust. The crust is the outermost shell layer of the Earth. It varies in thickness, being thin under oceans, 8 to 10 kilometers, and about 60 kilometers on the continents. It is formed from basaltic rocks and called sima, rich in silicon and magnesium. This is the oceanic plate, which is the continental crust, is formed from the granitic rocks, sial, which is rich in silicon and aluminum. Both crusts are always in what is known as isostatic balance. The mantle. The mantle forms more than 80% of the solid Earth and forms the base of the crust to a depth of about 2,900 kilometers. As you see, my dear students, this is the mantle area where we have convection currents. It goes under the two different ways at a specific place, which is a hot spot, and they start to going down when this material cools, they go down and getting hotter again, so they start to go up, and this is what is the currents inside the mantle area. This is very important to break down the earth and increasing the oceanic plate. In the other areas, the plates is minimized by going down to this area, and this plate will melt and go up as a volcano and adding new places in the ocean. As we know, we have a lot of volcanic islands in oceans, especially the Pacific Ocean. As you see, my dear students, the upper part of the mantle is partially molten and weak when compared with the strong and solid lithosphere above it, or the lower part below it, which is the lower mantle. It's also liquid rocks. This weak zone, about 350 kilometers thick, is regarded as consisting of rock material which believes as fluid under certain conditions resulting from temperature and pressure. And this is a situation that convection currents, as you see, may result in matter which permit the drifting of the contents, making this big fracture in the continents and start to drift it away from this point by adding the new molten rock material. The other sphere here is the core. We have also two parts of the core, outer core and inner core. The core is an innermost zone of Earth, a general with a diameter of about 3,486 kilometers. It forms about 1/6 of the Earth by volume. But being composed of very heavy materials, it makes about 1/3 of the Earth by weight. The pressure there, about a lot of millions of atmospheric pressure, and the temperature varies from 3,000 degrees centigrade to 500 degrees centigrade. And the density of this part varies from 10 to 13.5 grams per cubic centimeters in comparison to the average density of the Earth, which is about 5.5 grams cubic centimeters. The core is most probably composed of an alloy of iron and nickel. Studies on the mode propagation of the seismic waves through the different types of the Earth zones and initiated from the earthquakes help greatly in determining that the Earth's core could be divided in two parts of the core. The outer core with a thickness of 2,100 kilometers and consisting of molten iron and nickel with chrome. It's almost the same composition of the inner core, but it is molten. The core is solid and stands under pressure of 3 million atmospheric pressure and with a density of 10 grams per cubic centimeter. And the other internal core consists of material of very high density. It's about 14 grams per cubic centimeters and with a thickness of 1,350 kilometers. Studies also denote that the origin of the magnetic field of the Earth be generated from having these two internal and external core different in densities between the two cores in contact and with different phase together. This is gave us the magnetic field of the Earth. The atmosphere, it's another sphere. Now we talked about the lithosphere, the hard component of the Earth, from the crust to the core. Now we go up in the atmosphere. We'll find several spheres too. During the formation of our planet Earth, several elements and chemical compounds which were in contact with the molten material to be left in gaseous state and form later in time our atmosphere, which gets as high as 1,000 kilometers above the Earth's surface. The mass of the gaseous material has a lower density, and as we go higher from the Earth's surface. Also, the pressure of these gases as low as 1/2 of its value for every 5.5 kilometers high, till reaching the zero at the higher altitude. The most important constituents of the atmosphere as the type of gases is nitrogen, which forms 78%, and oxygen, which is 21%. It also includes small percentage of different elements as hydrogen, helium, argon, krypton, xenon, carbon dioxide, and ozone, with varying amount of water vapor. It can be also noticed that the atmosphere of oxygen becomes less and less at higher altitude, which gives human being a state of suffocation at high altitude. The atmosphere is also responsible for such natural features as twilight, which results from the reflection and refraction of light ray before sunrise and after sunset. Now, my dear students, we go to another sphere. Within these two spheres, lithosphere and atmosphere, we have another spheres like hydrospheres. During the formation of the solid Earth too and the surrounding atmosphere, a tremendous amount of water vapor has been condensated, resulting to heavy rain which fell down on the Earth's surface. This led to the formation of hydrosphere, which includes all oceanic basin rivers and lakes and cover 75% of the total surface area of the Earth, including water which fills the free space in rocks and soil. The hydrosphere is looked as the water surface surrounding the Earth from all sides, forming what is known as the sea level, which geologists consider it as the base level of defining elevations of major topographic features such as mountains, plains, plateaus, and valleys. Now, my dear students, we're going to the most important part of this chapter, which is the geologic structures. All types of rocks constituting the crust material of the Earth, particularly the sedimentary rocks, never stay as they have been deposited, but subjected from time to time to internal and external forces that play on the Earth and causing earthquakes, for example, regression and transgression of ocean water, and drifting of the continents, as well as make the rocks take forms other than those taken before. All of these forces will affect the sedimentary rocks. This form what is known as the tectonic and sedimentary structures, such as those represented by fold, faults, and cracks or joints. My dear students, we have types of these structures. Let's start with the primary structures. The type of structures which are different in their elements and properties from those defining the tectonic or secondary structures. So we'll use tectonic or secondary structures for tectonic processes, and for other processes we will use primary structures. This primary structures include those which complicate rocks of the crust under the influence of climatic and environmental conditions, such as the effect of heat, wind, water, currents. All of this will change the shape of the deposits and give it a new shape, and without any interaction from the tectonic forces. As example, such primary structures are cross bedding, grading bedding, as you see in the front view, ripple marks and mud cracks. All of these changes upon the sedimentary structures coming from the other processes or effects like wind, currents, waves. All of this will change the shape of the original rock. Here we have to mention about the theory of structures other than those which define either secondary or primary ones. Okay, as you see, my dear students, we separate the structures into primary, as we already seen on the sedimentary structures by the effect of the environmental changes. And the other type of structures, like the tectonic structures, we call it secondary structures. We have other types, those which have been initiated by the interaction between tectonic forces and the environmental effects, such as those which includes crystallization and metamorphic processes, are mostly observed in igneous and metamorphic rocks during the development. So these are also changes. There are changes affecting the rock after their primary formation. Types of tectonic structures. We have faults. These are considered to be one of the most important tectonic structures, and they appear quite clearly in sedimentary rocks too, because they consist of strata or layers of different thickness and extension. In spite of the fact that faults take different shapes and size, but the most familiar ones are the anticlines and synclines, and all being subjected to the geological setup. They cover land of Earth's crust, ranging in area between few meters to tens of square kilometers in one locality. And in most cases, most of them are characterized by cracks and fractures. All types of faults are always subjected to what is known as recumbent folding. Most of the faults could be described by the structural elements, which include axial plane, limbs, axes, and fold faces. As for the axial plane, it is defined as the plane which divides the fold into two equal parts, and it includes the axis which is defined. It also the description around the direction around which the sedimentary beds are bent. Sands and folds always consists of a succession of different layers, and each one of these layers has its own axis. Then axial plane should contain all these axes. Concerning the fold faces, we can say that fold contains two faces, one in the front and the other in its back. If we look to the fold along the line which perpendicular to the axial plane. Now, my dear students, we come to the end of our today's program. Until we meet next time, have my best wishes and goodbye.